We're going to deal with a few problems that are dealing with the two sum formulas we dealt with yesterday. Okay, they're going to give us some information. They're going to ask us to find something that's missing. So we're going to do some problems that deal with that, and we're also going to do some problems where we're going to take a arithmetic series and turn it into summation notation. So we're going to write a series in summation notation. So those are the two things we're doing today. It's going to take 6 examples to get through the notes. Alright, so on this first one, it wants me to find a sub n, and it gives me s sub n is 490, a sub 1 is -5, and n is 100. So we want to use one of our two sum formulas to help us figure out what a sub n is. What does a sub n represent?
Last number in the sequence.
Last term in the series. A sub n represents the last term in the series. So I need to choose one of my two sum formulas to find a sub n. Which sum formula do I want? First one or the second one?
Second one.
Why?
Because you need to find it. Oh no, this could be first one.
First one, why?
You have it. Where you have your in.
And the only formula that has a sub n in it is the first one. So that's what I want. So there's the formula. Now all I have to do is put in what they have given me and then solve for what they want me to solve for. So 490, n is 100, a sub 1 is -5, a sub n is what I'm looking for. So I just plugged in the information I was looking for. All right, what do you want to do next?
Solve for A, B.
Solve for a sub n. So what do you want to do to make that happen? This is 50, so then what do I want to do with that 50?
Subtract.
Divide by it. So if I divide by 50, we get 9.8. And then the only thing left is to add the 5, and I get a sub n equals 14.8. Okay, so what is a sub n? What did I find in 14.8? The last term in the series. Very good. Which term is it?
The last one.
Which one is it?
On what?
What term is it? What term is the last one?
A sub n.
Right. What number is it?
14.8.
No. Which one? Like if there is 300 terms, which term is this one?
300.
No. In this particular problem, which term is a sub n? If it's the last term, how many terms are in this problem?
14.8.
No!
Is this
Tanner, help me out, please.
100.
The 100th term.
Oh, okay. Oh, because
It's the last term, and there are 100 terms, so that means this is the 100th term in the series. All right, next one.
is that what n equals, or is that
N equal, we're trying to find n. This is what we want to find.
okay? I can tell.
So they're giving me this series, they're giving me the sum, and they're giving me a sub n. So what's one thing I know about my answer? Somebody say something.
So that can't be negative.
Can't be negative, and has to be what? It has to be a whole number. There we go. So it has to be a whole number. All right, so which formula do I want to use, first or second?
Second. First one.
First one. Why the first one?
That's given.
I have A of n, so I want the first one. So S of n equals n over 2, a sub 1 plus a sub n. So I know my S is negative 14. N is what I'm looking for. A sub 1 is negative 7. And a sub n is negative 3.5. Any questions on plugging that in? All right, now what? Multiply by 2. And negative 7. I didn't do that right. Something's not right. I didn't write the problem down right somehow. That 3.5 is supposed to be positive. There we go. So that was supposed to be positive. So when I put these two together, I get negative 3.5 there. And the only thing left, divide, and we end up with n equaling 8. So, pace. What term is 3.5?
The last term.
And more specifically?
Last term in the sequence.
More specifically?
The 8th term.
The 8th term. Very good. That is the 8th term. Is this right here? We just learned that there are 8 terms in the sequence. This one is my last term, so that has to be the 8th term. Very good. Alright, so this time they're giving me the sum. They're telling me a sub 1 is negative 19, and they want me to find the common difference. Sum is 1456, a sub 1 is negative 19. I'm looking for the common difference. So which formula do I want this time? The second one. Alright, so my sum is 1456. Do I know what n is? 26, yeah. Because n is that right there, 26. A sub 1 is negative 19. And then the common difference is what I'm looking for. So 26 divided by 2 is 13, and then what do I want to do with that 13? I want to divide, bless you. So when I divide, I get, oops, I did that wrong. 112. And I get negative 38 plus 25 times d.
What did you divide by? 2?
I turned this into 13, and then divided this by 13. Add the 38, and divide by 25. We get the common difference to be, yeah, 6 of it. Very good. All right, now we want to take arithmetic series and turn it into summation notation. We've got 3 of these. That's a semicolon. All right, so 6, 12, 18, ... 66. And they're telling me I equals 1. I want to write this as a summation. So what do I know has to be on the bottom of this summation?
I equals 1.
I equals 1. Okay, so whatever this is, that's what they want the bottom to be. Now, your book will tell you, instead of I equals 1, your book is going to say N equals 1. So when you get that, ignore that and change it to I, J, or K. Whichever one of those letters you like. Alright, now what do I want to do? 66 does not go on top. But I use the top number to get 66. Because when I plug the top number in to whatever my formula is, what do I have to get? I have to get 66. So that's how it comes into play.
Wouldn't you subtract 66 from 1?
Subtract what? No.
Or would you add it?
Subtract 66 from 6.
6 would be 60.
What?
Or divide.
The next thing we want to do is figure out what formula goes in here. Is what we're going to do.
So 6I.
6I?
Wouldn't it be?
Tell me.
Adding 6.
6I?
Oh no, it would be I plus 6.
It'd be I plus 6? Which one is it?
I think it'd be I plus.
11.
I think 6I will work. How can I check?
Try the first 3.
I plug in 1 and I get 6. I plug in 2 and I plug in 3 and I get 18. So this works. Okay, but I'm going to show, after we finish this problem, I'm going to come back and show you what I want you to do every time. So 6I works. Instead of having to guess, there's a way we can do something every time to get the answer. So now that I know this is 6I, how can I figure out what this top number is?
Find the difference. 66 by 6.
Say it again.
Divide 66 by
All right, why would I do that?
6.
So that's going to be your sum.
Because you're going to plug in the top one to I.
So when I plug something into 6I, it has to equal 66. So what you want to do is you want to take whatever your formula is and set it equal to your last number. So that means that top number has to be 11. So my summation notation, my answer is that complete thing. Because in the past, when we do these and people do quizzes and tests, for some reason, they don't give me this whole thing as the answer. They just give me part of it as an answer. It's got to be the whole thing that's my answer. This right here is my answer. Okay? Now, I want to show you a different way to get the formula. Anybody have another idea of what we can do to get the formula every time without having to think too hard? Okay?
I don't know if it's every time, but I just did the common difference divided by the last number.
That was to get the top, right?
Yeah.
That's not what I'm talking about. I'm talking about the formula that goes in here. What can I do every time that's going to give me that formula and make it pretty easy?
So it's pretty simple.
Yes. And it's something we've done here.
What I did is I just found the common difference and then I multiplied that by.
Good. What you want to do is use that formula from the explicit formula from the other day. Except, instead of putting an N in that spot, what do we want to put? We want to put I. So we want A sub I equals A sub 1 plus I minus 1 times the common difference. So in this case, I put 6 in there plus I minus 1 times my common difference of 6. And that is the same formula as what Brooklyn said. Because what happens when I distribute that 6 through? I'm going to get 6 plus 6I minus 6. And my 6's are going to cancel, and I end up with 6I. Okay. That's the easiest way to do it, is use that formula over there. All right, let's try another one. All right, 17 plus 21 plus 25 plus dot 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 plus 61. So the bottom of this summation needs to be I equals 4. And the next thing I want to do is find the formula. So what do I need to find the formula? A1, which is 17 plus I minus 1 equal, and then times the common difference, which is 4. Now, this one, that one is not correct. I need to make a small change to it to make it correct. What's different about this problem than the first problem? I equals 4. So what do you think needs to change in my formula to account for that?
I use
Say it again.
plug in.
Say it again.
Subtract.
What do you mean subtract 4?
Like instead of I minus 1, I minus 4.
I want I minus 4. Very good. Okay, so whatever this is also needs to be in that spot. And what can I do? What can I do to check to make sure I've got it correct?
Plug numbers in.
All I gotta do is plug it in. If I plug 4 in, 4 minus 4 is 0. 0 times 4 is still 0. 0 plus 17 is 17. So that tells me I did it right. If I had it initially, it would have been 4 minus 1, which was 3. 3 times 4 is 12, and 12 plus 17 is not 17. Okay? So all you got to do is whatever this number is here, make it the same one there, and it works. All right? Now I need to find my top number.
Plug it in the equation.
I don't plug it in.
Set
I set it equal to my equation. So I'm going to take 61 and set it equal to 17 plus I minus 4 times 4. Yes?
So you would distribute for, like, you would make it 1 plus 4i.
This right here?
Yeah.
Yeah, if you want to distribute, that's fine. And get 1 plus 4i, that's fine. Because still, when I plug in 4 times 4 is 16, plus 1 gives me 17. If you want to do that, I've got no problem with that. All right, what do we do over here to solve?
You'd subtract 17.
Subtract 17, which gives me 44. Divide by 4. And add 4, which gives me 15. So my complete answer is that right there. That's the answer I'm looking for. That's the summation notation that represents that arithmetic series. Okay? How many terms are in this arithmetic series?
50.
There's not 15 in there.
16.
Not 16. What'd you say?
14.
12. There are 12. Why are there 12?
Top
Top minus bottom plus 1. So 15 minus 4 gives me 11 plus 1 tells me there are 12 terms. So what term is 61?
12.
It's the 12th term. Okay. All right, one more. All right, so I have negative 13 fifths plus negative 12 fifths plus negative 11 fifths plus dot 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 negative 3 fifths, and they want I to start out at 2. So that means I equals 2 down here on the bottom. So what formula needs to go inside?
The A1 plus I
So
minus
negative 13 over 5 plus I minus what in this case? 2 times what? What's my common difference?
1.
1/5. If we we can't tell what our common difference is by looking at it, what do we do to get it?
First equation is
Second.
We don't need an equation.
Subtract it.
Yeah, you just take the second one minus the first one. So these cancel. Negative 12/5 plus 13/5 gives me 1/5. Alright, so now I need to get the top number. Megan, what do I do to get the top number?
You have to set it equal to the equation.
Set what equal to the equation?
Last number.
In last term, so negative 3/5 I set equal to the equation. Alright, what do we want to do to make it easy to solve this equation over there?
Multiply by 5.
Multiply by 5, because if I multiply by 5, all my 5s are gone. And I add 13, which gives me 10. And I add 2, which gives me 12. So my top number needs to be 12, and all of this together makes up my solution. That is the summation notation for that arithmetic series. Seth, how many terms are in this series? 11. Very good. There are 11 terms in this series. Questions on writing an arithmetic series in summation notation? All right.
That's like it's looking at me like,
Page 606, 58 to 68, even, and 69.